I'm taking a look at question number 6 on the performance-based assessment for Algebra 1 using the Park Online Practice Test. Okay, the story here says a tennis ball was 2 feet off the ground when a tennis player hit it so that the ball traveled up in the air before coming back to the ground. It says the height of the tennis ball is described by the graph shown. The numbers along the x-axis represent time in seconds after the ball was hit, and the numbers along the y-axis represent the height in feet of the ball at time x. So I can see, if I just look at this, I can see that at time 0, the height of the ball was 2 feet. And then it traveled up so that at 1/4 of a second, at a 0.25 seconds, the height of the ball was 5 feet. And then at half a second into the bounce, the height of the ball was 6 feet. And then it turned around and headed down so that at 0.75 seconds, 3/4 of a second into the bounce, the height was 5 feet again. And then at the 1 second mark, the height of the ball was 2 feet. And then shortly after the 1 second mark, it hit the ground. So that's kind of analyzing the graph. That's what we can see there. And the question here says to use the graph to estimate the average rate of change of the height of the ball for the first 0.25 seconds after the ball was hit. Okay, average rate of change, I've said in my classes, is fancy for what's the slope? What's the slope of the line for the first 0.25 seconds? So I can see, starting at time 0, right here, the height of the ball was 2 feet, and then at the 0.25 second mark, the height of the ball was 5 feet. If I want to find the slope between those 2 points on the graph, we can use this formula here. Slope equals y2 minus y1 over x2 minus x1. And so if I'm writing my ordered pairs for the first 0.25 seconds, my first ordered pair, if I do ordered pairs as time and then height for the x and y coordinates, then I have 2 points. I have the point 0, 2, and then I have the point 0.25, 5. And I've shown in my classes that to find the slope when we have 2 ordered pairs, we can take y2 minus y1 over x2 minus x1. And in this case, it will be 5 minus 2 divided by 0.25 minus 0, which gives us 5 minus 2, that's 3, and 0.25 minus 0 is 0.25. Now, at this point, this is a no calculator portion of the test. You have to be able to figure out what 3 divided by 0.25 is. You have 4 choices. I would suggest maybe thinking of this, you could think of it as 3 divided by 1/4. If you know that to divide by a fraction, you multiply by its reciprocal. Then 3 divided by 1/4 means 3 times 4 over 1, which is 12. So that's one way you could do this without a calculator. Or you could think of 0.25 as 25 cents. Okay, if you take 3, say $3, and divide it by 25 cents, you're going to have 12 quarters in $3, right? So somehow you've got to be able to figure that out. Basically, it comes down to the average rate of change is C, 12 feet per second. I was going to say one more thing about this. Again, if you consider the fact that in this graph, we increased 3 feet in 0.25 seconds, then it makes sense that it would be 12 feet in 1 second. Just using some proportional reasoning there. Again, if you can increase, if the ball is increasing 3 feet in 1 second, or sorry, in 0.25 seconds, then it's going to increase 12 feet in a full second. So there we go. That's one way to go about this problem.